All right, so I'm recording now, and then I'm going to share my notebook screen with you. Okay, so here we are. So guys, let's talk about what we did last time. So we are continuing with the same section. So remember last time we introduced this implicit differentiation. So for example, if I asked you to, like if I gave you an equation, let's say I've got x cubed plus y to the fourth equals 8. And I wanted you to find the derivative, dy dx, with implicit differentiation. It means, y is not by itself, but we're not going to solve for y. We're just going to take the derivative of the equation as is, and we take the derivative of each term. And remember that y, when you take the derivative like this, the rules apply to y just like they do to x. It's just that anytime we do take a derivative of a term with y in it, we have to add on that dy dx term. So in this example, you take the derivative of x cubed and get your 3x squared as normal. The derivative of y to the fourth is 4y cubed, but because it's a y, we have to add on that dy dx term. And then over here, the derivative of 8 is 0. And then from there, remember all I really did was I just got the dy dx isolated. So I would subtract 3x squared from both sides. Then I would have 4y cubed dy dx equals negative 3x squared. And then I just divided both sides by the 4y cubed. And I got that dy dx equals just negative 3x squared over 4y cubed. And then that was that. So I did a lot of problems like that where we took the derivative of each term as is, and then we solved for dy dx. So what I want to do now is I'm going to start this problem just like we did over here. So let's use the same equation, x cubed plus y to the fourth equals 8. But the instructions are going to change just a little bit. This time, I want to find dy dx at a certain point, because I want to know how to take the derivative like we did here, but I should also be able to find the derivative at any point. And we did that with the regular differentiation. So you guys, you're going to see find dy dx at, and then it's going to give you a point. Let's use 1, 0. Now this extra little piece, putting that point in there, actually makes our lives easier. It is a step we have to know to add in, but let's see how we're going to do this, guys. Your first step is actually the same as it was over here. You just take the derivative of each term. So we still get the 3x squared plus 4y cubed dy dx equals 0. But once you take the derivative of everything, don't worry about isolating your dy dx yet. After you take the derivative of each term, this is where we're going to put in the 0.10. So everywhere there's an x in your problem here, you're going to put a 1 in there. And everywhere there's a y, oh, hold on. This is going to be bad. Let's change this point to 0, 1. You guys, if I put y equals 0 in there, then your dy dx goes away. And that's not very helpful for example purposes. Sorry, let's call our point 0, 1. So after you took the derivative like we did, we're going to put a 0 in for each x and a 1 in for each y. So I'm going to have 3 times 0 squared plus 4 times 1 cubed dy dx equals 0. So now you still need to isolate dy dx, but when you put in these real numbers for x and y, it makes it a lot easier because look, what happens to this entire term? Well, it just goes away because you have that 0 there. So I have 4. Now 1 cubed is just 1. So this is just 4 dy dx equals 0. And then just divide both sides by 4. It's still going to be 0 over there, right? So you just get dy dx equals 0. So what did we find? Well, over here we found the general derivative for any point on the function, right? You pick a point, you put those in for x and y, and you get the derivative at that point. Remember, the derivative is always the slope of the tangent line at any given point. So what we found over here is at 0, 1, the slope of the tangent line is 0. So the difference between here and here, this is just in general, this is what we did last time, and we got this term with x and y's in it. But over here, we actually put in a value for x and y, and your answer is just going to be a number because it's going to be like a slope, right? So let's do another one.
I actually have a question real quick.
Sure.
Where did the cubed on the 4 times 1 go? Like, why did that go away again?
Oh, 1 cubed is just 1.
Oh, okay, that makes sense. Okay, thank you.
Okay. So let's do another one. Example. You guys, let's make it a little bit harder. Let's do 2x squared minus 3y cubed. So 2x squared minus 3y cubed equals, and on the other side, I have 5x minus 3y. So not a lot harder, but notice that on all the problems we did last time and this one I just did, I only had a constant number on this right side, so it always turned to 0. I'm not going to have that 0 on the right side this time. So let's go ahead and start. So on this one, you guys, I want to find dy dx. Again, at the point 0, 1. It's 0, 1 a lot, guys. Sometimes it's 1, 1. Sometimes it's 1, 0, but it's always a pretty easy point. So I want to find it at 0, 1. Remember, your first step is the same as we did last time. You just take the derivative first. So derivative of 2x squared gives us 4x minus the derivative of 3y cubed is going to be 9y squared dy dx equals, you guys, derivative of 5x is 5 minus the derivative of 3y is 3 dy dx. Remember, every term that has a y in it gets a dy dx when you take the derivative. So notice I do have dy dx on both sides now. So isolating it would require me combining the dy dx's on one side and then doing some factoring. We could do it, but you guys, the algebra is a little bit harder. But remember, I have a point to put in, and once you take the derivative of everything, you can now put in your point at 0, 1, and it's going to make the algebra a lot simpler for us, because if x is 0, then we have 4 times 0 minus 9 is 1, so we get 9 times 1 squared dy dx equals, now nothing gets subbed in over here because on this side we didn't have any just x's and y's left. So over here it looks the same, 5 minus 3 dy dx. So notice the 4 times 0, that just goes away. 1 squared is just 1, so we get just minus 9 dy dx equals 5 minus 3 dy dx. So remember, our goal is to solve for dy dx, so let's go ahead and combine those dy dx terms. Now, dy dx, even though it's like a fraction, and a lot of times we see it as just something totally different, it's just a variable. You guys, it's just like x, it's just like y. So you can add, oh, uh-oh, something happened. You guys, my sharing somehow stopped. Let me go. Where did it go? Hold on. Somehow my note page just got closed out. Oh, okay, I got it back. So now I gotta have to share it with you again. I don't know what just happened there, but Let me share screen again. Note, share. Okay, so we should be back. So again, you treat dy dx like any other variable. You can add 3 dy dx to both sides. So over here, guys, you have minus 9 dy dx plus 3 dy dx. So minus 9 plus 3, that would leave us with negative 6 dy dx. We combine it just like any other term. Like if this had said minus 9x plus 3x, if it was just x's there, we knew we would get negative 6x. It's just our x's were dy dx's, but they work the same way. So we have negative 6 dy dx equals, and the only thing left on this side is 5. So now to isolate dy dx, we just divide both sides by negative 6 and get dy dx equals just negative 5, 6. You guys, this is the slope of the tangent line on this function at this point 0, 1. So let's see. Let me think of, we need to do one with a product rule in it. So let's do that next. So this is, this implicit stuff is just a lot of examples. Working through examples is the best way to really understand it. So that's what we're doing, guys. I'm just trying to make sure I get at least one example of each type of problem you're going to see. So on this one, I've got a product rule. I want to do 7x squared y to the 5th. That's the one side, so let me get that down. So I have 7x squared y to the 5th equals, it equals 1 minus x squared minus y. So equals 1 minus x squared minus y. So this is the equation. I'm going to find dy dx for this equation. And the point I want to find it at, again, you guys, is 0, 1. Okay, so I can do this. You guys, this is product rule, though. You guys, this is 7x squared times y to the 5th. So I see a u and a v there. So if u is 7x squared, then du will be 14x. If v is going to be my y to the 5th, then I'll have dv is 5y to the 4th. Don't forget dy dx because that's a y term. So let's take the derivative of this side over here using the product rule. So it's going to be u times dv. So I have 7x squared times 5y to the 4th dy dx plus v, which is just y to the 5th, times du, which is 14x. So you guys, this is the derivative of that side using the product rule. Then on the other side, it's just regular power rule and stuff like that. You guys, I have a 1, take the derivative, that turns to a 0. I have minus x squared, that's going to become minus 2x. And then you have minus y. You guys, sometimes when it's y by itself, you know, you kind of forget how to do the derivative of that. Remember, if you have x, the derivative of x is just 1. Well, the derivative of y is just 1 also, but because it's a y, you get that dy dx in there. So this minus y, when you take the derivative, is just minus dy dx. So you guys, at this point, it looks really difficult. Like there's a lot going on here. You know, dy dx is in 2 different places. I have lots of powers and variables all over the place. But remember, now that I'm done taking the derivative, I get to put in my point at 0, 1. So every x becomes a 0, every y becomes a 1, and this problem gets exponentially more simple. So you guys, if you put an x equals 0 in here, what happens to this entire term? You guys, because isn't this all just multiplied together? You guys, this entire term goes away because of that one x value equaling 0. So this is just gone. What about if I put x equals 0 here? What happens to this whole term? it goes. You guys, it becomes 0. All you have on that side is a big old 0. So that did get a lot simpler. And what happens on the other side? So this is already a 0. So obviously that's a 0 minus. What happens to this term? It becomes 0 because x is 0. All that's left over here is minus dy dx. So you guys, look how much easier that got once I put in that point. So negative dy dx equals 0. You guys, if you really want to think about it, you could divide both sides by -1 to get rid of that negative. Either way, you're going to have 0 equals dy dx. If negative dy dx is 0, positive dy dx is also 0, right? So we got 0. You guys, that is the slope of the tangent line for this function at the point 0, 1. So yeah, sometimes having that point to put in, even though it's an extra step, just makes your algebra so much easier. So it's kind of nice sometimes to have that extra step. Here, I'm going to leave this here while I pick another problem to do. I think we need to do a problem with e's in it. So let's do a problem like that with e's. On this one, I have 2x times e to the 5y equals 2. So 2x times e to the 5y equals 2. And you guys, the point I want to evaluate dy dx at for this one is actually 1, 0. So I'm going to find dy dx at 1, 0. So it's a little different. Guys, this time x is 1 and y is 0. So, so let's get started. Guys, this is product rule again. You see the 2x and the e to the 5y as two products. What is happening? Okay. All right. Sorry, I have a bunch of, it like was stuck on right click. I was trying to get rid of it. Okay. Anyway, guys, so we have a u and v. So u is going to be 2x, which means that du is 2. V will be your e to the 5y. So let's find the derivative of v. So remember how exponentials work. The e term comes down exactly as is. So we have the e to the 5y. And then you just multiply by the derivative of your exponent. So the derivative of 5y is 5, but because it's a y, it's dy dx. So let's put it together in the product rule. So we get u times the derivative of v. So there's a lot going on here, lots of multiplication, right? Plus v, which is just e to the 5y, times the derivative of u, which is just a 2. And then you guys, the derivative of the other side is just 0. Boys. Okay. So, this looks so complicated, right? But this is where you put in the point 1, 0, and it's going to get a lot better. So everywhere there's an x, it's going to be a 1 this time, and the y's are all going to be 0. So let's see what happens. Let's put all those in. So you're going to have 2 times 1. Here you're going to have e to the 5 times 0, because y is 0 this time. Then you have times 5, and then the dy dx, plus e to the 5 times 0 again, y is 0, times 2 equals 0. Okay, so let's clean this up a little bit. You guys, we have the 2 times 1 here, and we have times 5 here. So let's put those together. So 2 times 5 here. You can call this 10 times e to the, what's 5 times 0? That's just 0, right? So I have 10 e to the 0 dy dx. Plus, you guys, again, you're going to have another e to the 0. And this one is times 2. And that equals 0. So I've put everything in and I've simplified it. Here's what we need to know. We need to know that when you raise anything, so whether it's e, whether it's a number, what happens when you raise a number to the 0 power?
Becomes 1.
Right, it equals 1, and that's so great for us right now. So you guys, this e to the 0, don't let the e throw you off. Because it's to the 0 power, it just equals 1. So this is just a 1, and this is also just a 1. So if those are two, if those two things are just 1, really we just have 10 dy dx plus 2 equals 0. And then it's real easy to isolate dy dx from here. Let's subtract 2 from both sides. And then I have 10 dy dx equals negative 2. And then all I got to do is divide both sides by 10. So dy dx equals negative 2/10, or I would reduce that and call it negative 1/5. So you guys, you'll notice that the point it gives you is usually a point that makes the problem easier to solve. Like y being 0 there, having 0 in that power was very helpful to us because it just made that whole term equal 1. So this is something you want to remember. You're going to see it again when you're doing your homework. Knowing that fact is going to make your life a lot easier on a problem like that. So you guys, I want to take this one a step further. So we found the derivative at 1, 0, or the slope of the tangent line at 1, 0, right? Well, if I have the slope, I might as well go on and find the equation of that line, of the tangent line. We actually have all the pieces that you need already, so this is not a far stretch. So notice in implicit, so remember when we were first learning how to do derivatives, there was a couple of times where we found the derivative, but then I asked for the equation of the tangent line at a certain point. Boys, shut it. Sorry. So I asked for the whole equation. So we used y equals mx plus b to help us get there. Now you know that m, the slope, is actually just your derivative, right? Because derivative is the slope of that tangent line. So we already had m, but the problem was finding b. So what we had to do was we had to find an xy pair that was on the graph of the function and plug that in to help solve for b. But you guys, it's even easier in this case because look, we already have m. We just found our slope of this line is negative 1/5, and we already have a point. You guys, we already know the point on this line because it was given in the problem. So the point you're going to use is the 1, 0. You're going to put the 1, 0 in here for x and y, and you're going to put your slope in, and you're going to solve for b. So you guys, finding the equation of a tangent line after everything we've already done should be a pretty simple step as long as you remember how to do it. So remember, this is where, let's go ahead and put in the slope. So we have y equals negative 1/5 x plus b. Now that you have the slope in there, use your point where x is 1 and y is 0 to get 0 equals negative 1/5 times 1 plus b. Remember this step, when you put in that point, you're just solving for b. So you get 0 equals negative 1/5 plus b. And to get b by itself, let's add 1/5 to both sides. So over here, you'll just have positive 1/5 equals b. So b equals 1/5 isn't your equation, right? But you put that 1/5 into your equation for b. So the equation of the tangent line on this one is you put in your slope of negative 1/5. So y would equal negative 1/5 x plus b, which you just found, is 1/5. Parker. I'm glad you're having fun, but you gotta be quiet. Okay, so you guys, we did a lot on this one, so let's summarize. So we started with this equation here, the 2x e to the 5y equals 2. we wanted to find dy dx at the point 1, 0. So the first thing we did was we took the derivative of everything using all that product rule. Once we did find the derivative of everything, that's when we put in x is 1 and y is 0. You guys, that actually got us all the way down to here, putting those in, and then we solved for dy dx. We got negative 1/5, which in turn, remember, is the slope of the tangent line. So to go ahead and find the equation of the tangent line, I used that slope of negative 1/5. I used the point given, and I put them into this formula, y equals mx plus b. I solved for b. And then when I had b and m, I put them into the equation. So there was a lot happening. You really just want to take it one step at a time. So let's see. If you have a problem, and I can't exactly remember how it's worded on your homework, I think the homework just says find the equation of the tangent line. But you guys, to do that, you have to do each of these steps that we did, because you got to know the slope of the tangent line, which means you got to find dy dx. You have to put in that point. You have to do all of these steps, even if it just says this part. So just keep that in mind. If you have the equation of the tangent line problem, I want to say on your homework, I made it a little bit an easier problem. I don't think I had e's in it, but you do have one. It says find the equation of the tangent line. You might reference this or write down the steps that we did, you know, so you'll know how to get to that point. Basically doing the same thing we do on all the other problems with the extra step of the y equals mx plus b. You guys, I want to do one more problem. This next one's not going to be an equation problem. Come on, no, I guess as far as it goes. But I want to do one with natural log. So you guys, on this problem, I have x times the natural log of y equals 1. And you guys, here's the thing. I want to evaluate this at the point 1e. So you guys, where x is 1 and y is e. Remember, e is just a number. So it makes sense. It's just we don't usually put in e for, you know, our y or our x. But I promise you, as we work this problem, you're going to see that this point is making it easier for us to do this problem. So let's get started though, you guys. This is product rule. This is x times the natural log of y. So when I take the derivative of everything, u is going to be x, which means du is just 1. V is the natural log of y, which means when I take the derivative of v, remember I'm going to get 1 over y, but because there's a y in there, I get my dy dx. So let's put that together with the product rule. So it's u times derivative of v. So x times 1 over y dy dx plus v, which is natural log y, times the derivative of u, which is just 1. On the other side, this 1 just turns into a 0. Now that I've taken the derivative of the function, I can now put in my x and y values of 1 for x and e for the y's. So let's see what happens. If I put in x equals 1, this becomes 1 times 1 over e dy dx plus natural log e, putting that e in for that y. I'm going to leave off this times 1. So I have this. Now, you might not think that this looks better because we still have e's in there, and we don't usually like to deal with e's. Let's simplify a little bit though. You guys, 1 times 1 over e, that's just 1 over e. So I just have 1 over e dy dx plus, let's talk about the natural log of e. You guys, does anybody remember what the natural log of e is? It's okay if you don't. Well, the natural log of e is 1. If you want a background for that, and it's okay if you don't, I'm going to give the background for it, just so you know you believe that what I'm saying is true. Remember what natural log is? It's really the log base e. But if we're taking the log with a base of e, we just say natural log instead of log base e. So the natural log of e, written in another way, is the log base e of e. And if you remember anything about logarithmic functions, what this statement says is you take your base, and the base goes here. The base needs to be raised to a power to get the end result of this number here. So e to raised to some power has to equal e. That's what natural log e is telling us. So, Jack, really? Sorry. What does this power have to be? When you answer a log equation, your answer is always the missing power in this, this equation here. So I'm saying e raised to some power equals e. What's my missing power? Well, if you start with e and you end with e, your missing power has to be 1. So this is why the natural log of e equals 1. And again, if you want to ignore that, that's okay. You've learned it in the past somewhere. But the natural log of e is just 1. That's why this is nice. That's why putting an e in for that y value is wonderful, because then we get this natural log of e, and I can just say that that's 1. And then I get equals 0. So you guys, this is one of those facts, like remembering when you raise something to the 0 power, it equals 1. This is another fact you want to remember. And then from here, it's pretty easy to solve for dy dx. Let's subtract 1 on both sides. Then I have 1 over e dy dx equals -1. So to get dy dx by itself, I need to divide both sides by 1 over e. Remember, when you divide by a fraction, it's the same as multiplying by its reciprocal. So dy dx is going to equal -1. So instead of saying divided by 1 over e, let's say times e over 1. So what does that leave us with? Well, I think it just leaves us with -e. So yeah, guys, your dy dx at the point 1 comma e is just -e. And you might look at that and say, what, aren't I supposed to just get a number on these? How could e be the slope of a tangent line? Well, it is, right? E is just a number. So it's fine, even though it says e there. It's not a variable. So you guys, I'm not going to find the equation of the tangent line on that one. And you wouldn't have to either on a problem like this. I basically wanted to do this one for this very specific fact, because you will see it again. And you guys, even though we did end up with e in our answer, that's okay. It wasn't hard to work with from this point. So, so guys, I think the biggest thing you have to remember on this stuff is that you're always given a point to put in. You cannot put in that point until you take the derivative. So you can't just put 1 and e in here. You guys, you have to take the derivative first, like we did right here, and then you can put in your point. So always take the derivative first, then put in your point. That's going to be the biggest thing you have to watch out for. So just keep that in mind. And then if you do have to find the equation of the tangent line, which there's just one of those like that, you'll go ahead and you'll do all the steps. You take the derivative, then you put in your point, you find the slope of the line in dy dx, you use this point to solve for b. But I think you guys will be fine other than that. Every problem we've done here is very similar to a problem you'll see on your homework. So yes, I'm trying to think if I have anything else. Oh, guys, so I guess for those of you who are here, I'll probably email about it too. So I've decided at this point, judging from feedback I've gotten from you guys, and judging from the lack of feedback I've gotten from anybody with a different opinion, we're going to stay Zooming, you guys. So even on Fridays, we're going to stay on Zoom. I honestly, I didn't know what to expect as far as feedback on this stuff would go. I got a lot of feedback in favor of us being online all the time. You know, whether it's a schedule issue, like I know I've got my softball girls. It's just easier for you guys to Zoom in. I have some people with work schedules that it just makes it easier. You guys, we never have to deal with parking, you know. So you guys, we're going to stay online. It sounds like the majority of you, that's what you want. If it wasn't what you wanted, I'm sorry, I didn't hear from you though. So I'm assuming everybody's okay with it. So yes, so on Friday, guys, we'll just Zoom still. And if for some reason there gets to be a point where it doesn't work for us, we'll talk about it then, but I think it's working okay. You know, I'm always here to answer questions anytime. If you do want some more one-on-one, you know, help with anything, you know where to find me. You can email me. We can set up private Zoom meetings. And I think with doing all that and being available, it makes this a little bit easier for you guys to be online. But anyway, that's all I have for you. So that homework 12.4 part 2 is up in MathLab right now. So 12.4 1 and 2 is what are going to be due on Sunday night. So I will just see you guys on Friday and we'll move on.